All right, recorded rolling. So Thursday, August 22nd. Today's going to be day one of a two-day lab. So back in the lab stations, you guys see lab stations, there's a bunch of inclines set up. There's also back there a bunch of Hot Wheels cars. There's some lab weights, and there's a bunch of measuring tools. Right, so you guys got like meter six back there. You guys got protractors. You guys got stopwatches, these little speed gates. And let me show you how to use all those today. But here's the question that we're aiming for: is what equation or equations could govern the motion of a car rolling down this incline at some angle from the horizontal? Okay? Now that's going to be a control variable for everyone. So let's just leave the angle locked in place. We're not going to touch that for a few weeks. Okay. So however many degrees that is. So, okay, so you guys got a protractor back there. One thing you'll keep track of is like how many degrees is this from the horizontal, and then leave that locked in place. Okay. And then have to figure out what other equations could govern the motion of that car. Right? Notice that it'll be going in a straight line, right? You guys see this car just rolling in a straight line. Okay. Okay, so this is going to be the first main topic of this class. Right? We're kicking off today, which is linear motion. Linear motion. How do things move in straight lines? Right, uniform, right? Right, so I think everybody has this lab table. Everybody's got this lab table. Okay. Notice it's pretty blank. I mean, there's a structure of a table there, but I didn't throw anything in. But if you think about the labs we've done so far, you can probably figure out it's going to be some kind of variable, some kind of unit. Right? Maybe, for example, you want to measure what is the mass of the car in grams, how far is it rolled, distance in centimeters or meters, how much time did it take to roll in seconds. That could possibly be some variables, right? Right, variable unit, variable unit, variable unit. You guys see that? Also, here's good lab practices to do like 3 runs and take an average. So before you change any variables, right? Especially if you're working with a stopwatch, because it's really tricky to get the time exactly right. So sometimes you're a little fast, sometimes you're a little slow. Right? So you'll get some setup, do 3, try 1, 2, 3, maybe take an average of the times, right? Before you change something. Now, what are you going to change? It depends. And on what set of variables you have. Right, we're going to because there's lots of variables floating around. Guys, what's one variable that could possibly affect the motion of the car? What do you guys think? What's one variable? What do you think? Yeah, how about the mass of the car, right? How about the mass of the car? So mass can be a variable. No, I'll tell you, a blank car is approximately 33 grams. There is one digital scale back there. I couldn't get my hands on the triple B balance. Sorry about that. Somebody else is borrowing it right now. But if you can't quite access the digital scale, you can call a blank car about 33 grams. That would be plenty good enough for this lab, right? And also, you guys got some lab weights. So you could tape on lab weights to the car and increase the mass that way, right? So see if you guys can follow. If I have 33 gram empty car, and I want to say, well, what does mass have to do with the motion of the car? And I tape on this 50 grams, as what's 33 plus 50. I mean 83. So now I got 83 grams. Zip it down. Right? You guys get that? Let's do a quick hypothesis. Right? So as I make the car more and more and more massive, now some of you guys are going to do that, but not everybody. Right? Here, I'll get to that later. Who's going to do what? Right? If I make the car more and more and more massive, that's going to do one of 3 things. Either it's going to make the car zip down faster, or maybe it zips down slower. It's like more massive. Like, it takes forever to get down. Or maybe it makes no difference. Maybe I have a light car next to a heavy car, and they're going to tie every time. Huh. Let's see, show hands. You guys are ready to hypothesize? This is the hypothesis we're going to do. Right? How do you guys think a more massive car is going to zip down really fast? Who thinks that? Ooh, okay. Who thinks a more massive car is going to slow down? It's going to take it more time to reach the bottom. Who thinks that a more massive car is going to tie with a lighter car? They're all going to tie. Okay, so we got different hypotheses floating around. And yeah, you guys gonna know by the weekend, right? You guys said? Okay, now that's just one experiment. Oh, guys, what's another variable you think they could either change or monitor? How about this? Right, I'm just gonna go ahead and show you the 4 different experiments that you guys are gonna have going back there. Now, there's 4 lab tables. There's 2 stations per table. There's a bunch of different stations. I threw a bunch of playing cards back there. You guys see some playing card suits, right? So if there's a bunch of variables, see if you guys remember this. Ideally, if you can have a really well-designed experiment, you want how many independent variables at a time? Just one thing that you're changing. And then maybe there's like 5 variables floating around. Okay, change one. You leave everything else controlled as much as you can. Maybe there's another variable that changes, and that's called the dependent variable. Right, so we're going to look at different facets of the motion of this car, and then we'll come back together and come up with like some master plan equation that's going to govern the motion of the car. Right. So if you see the clubs back there, if you go to a station that has clubs, I want you guys to do this experiment. Okay, this is the one we just talked about. Change the mass of the car and say how much time does it take to roll down the incline. You guys know how to use the stopwatch? Start, stop, reset, start, stop, reset. Right, you guys can do your stopwatch. Right. Now, if you do this one, okay, you're controlling the angle. Of course, everybody's controlling the angle, so don't change the angle of the incline. Okay? But you're also controlling the distance. So if the car is rolling 200 centimeters, just let it keep rolling 200 centimeters every time, all the way down. Okay. Right. Now, you'll be changing the mass of the car. Right? You'll have light cars, medium cars, and heavy cars. Well, maybe use the same car for the same wheels over and over. But you can tape on lab weights. You guys get the idea? Make more massive. Right? See how does that affect the time? Right? And how do you guys hypothesize what's going to happen? Right, you guys good with the clubs? Okay, let's go into spades. Yeah, if you see the spades back there, go to the station with spades. I want you to figure out what's the relationship between distance and time. So notice independent variable distance. So does that mean you're going to change the rolling distance? Yeah, that's exactly what that means. So let it go maybe 50 centimeters. How much time does that take to roll 50 centimeters? Then let it go 100 centimeters. How much time? Then 150 centimeters. How much time? Okay. No, do like 3 runs per trial. So you do like 50, 50, 50, then 100, 100, 100, 150, 150, 150. Yeah, it's getting there, right? Then time it. Maybe take an average time, right? And then you would be controlling these variables, angle, of course, but also mass of the car. So guys, if you have the spades, are you taking on lab weights? No. You could just use the same blank car over and over and over again. It's probably the easiest way. Right? You guys got that? Right. If you have, the hearts and the diamonds are pretty similar. Let me go to hearts. Hearts, speed versus distance. So if I go back to my setup here, you guys see this finish line here? Maybe the car goes through the finish line. Oh, what are these variables, right? Like M could be mass, X could be distance, T could be time, right? What do you guys think the V stands for in physics? Velocity is what I'm looking for. Velocity, right? It's kind of a physics term for speed, but it also sort of implies direction. It's like a vector value, what we'll talk about. Right? You could call it speed today. That's okay, because it's just going in a straight line, right? So how can you get that? Well, one way you could do it is I've got all these speed gates back there. You guys see a speed gate? Right? And a car goes through it. It'll just fit a car through. So here's like from underneath, right? Did it out from above, go through like that. And I'll tell you how fast it's going. Let me show you guys an example. If I turn this on, boink, right? It's got 2 little sensors here. If I run my finger past the sensors, it says, oh, it didn't get it. It's 2.44 meters per second. You guys see that? 2.44 meters per second, right? And then you can reset it. Yeah, there. No, oh, it does say meters per second. There's a way to change the units, but ideally that's what we're looking for. Okay, meters per second. Okay. All right. So you guys got right now there is here, hold those down to run this off. Okay. There is another velocity tool. Oh, where is it? Oh, here. All right. It's this one here. This one, I don't know. You can try this out if you want to, but this one works a little differently. So you have to either hook this up to your phone or a school laptop, but the school laptop I think needs some software or something. I don't know, right? So this may or may not work, right? Some students were trying this last class and it's kind of iffy, right? But you want the car to be headed straight towards this or away from this. You can either be going towards or away from this detector. And this detector can pull a bunch of information on your phone or your laptop. So it can tell you its location and also how fast. And if it's speeding up or slowing down, it has a way to say that too. It's called acceleration. Okay, right. So that's kind of, if you want to get your hands on that, it's optional. It's back there. Okay. Right, but this is, I think the speed gate's a lot more reliable. Okay. Okay, and okay, so you guys good so far? Finally, this diamonds. This diamonds is almost the same as the hearts, except you're keeping track of different variable. Instead of saying speed and distance, let's do speed and time. Right? Now, you do have to change the distance to change the time. Right? Like, do you guys think if the car is rolling a further distance, it also takes more time? Right? And that would make sense, right? Those are not independent of each other, right? But you're using the stopwatch instead of keeping track of how far. I mean, you could keep track of how far also, but it's just not going to show up in your graph. Okay, I guess that. Right. let's do some more hypothesizing. Right, so you guys hypothesize for if you change the mass of the car, what that's going to do. Right, it's going to zip down faster, slower, the same. Right. Let's do distance and time. So maybe it's kind of obvious if the car's rolling a further distance, it's going to take more time to do that. That would make sense, right? But how about this? Do you guys think that that's a linear relationship or something different? Like, for example, if it's double the distance, do you think it's double the time? Or do you think if it's double the distance, it's more time, but it's something different than double? Let me see, show of hands. Let's hypothesize. We'll just narrow it down to that. How many guys think that if it's double the distance, it's also double the time? Who thinks that? How many guys think if you double the distance, it'll increase the time, but it's something different than double? How many guys think that? Okay, all right, so we got some hypothesis. Go down. Right. How about speed and distance? Let's do the same sort hypothesis. Right. If you double the distance, is that going to double the speed, or is it going to do something different? How many guys think if you double the distance, it will pretty close to double the speed? How many guys think if you double the distance, yeah, speed will increase, but it'd be something different than double? Okay, so we got that hypothesis, right? And now the diamonds, which again is pretty similar to hearts, but now we're looking at time. How many guys think? Right, let's say you let it roll for double the time. Maybe I'll do it that way. Right? If you double the time that it rolls from 1 second to 2 seconds, how many guys think if you double the time that it's been rolling for, it'll also double the speed? Who thinks that? Who thinks if it's double the time, yeah, it's going faster, but it's something different than double? Who thinks that? All right. So now we got some hypotheses floating around. All right. Again, you guys will find what's back there. Let's look up. We got. Who's got any questions so far? Any questions so far? All right. In case I use this video for all my classes, this page is only for my AP students. Right. So AP right up here. I'll just do this real fast. Is there's always some AP format. There's going to be a free response question for them in May. There's going to be some question they get. They have to list what measuring tools they're using. Give an example here. Free procedure, usually like 5 to 7 steps. I usually lab setup, set up an incline, let the car roll down, and then I change this variable. I use this tool to measure this thing, kind of thing. Right. We're going to do some graphs and then come up with a conclusion that answers whatever question. Again, there's like 4 different questions, individual questions. Right. Now, again, that's only for my AP students, but I just want to put that in their video recording. Right. Now, back to something that everybody's doing is, if you guys see on the back of your lab table is just a set of graph axes. Right? So I gave everybody this lab table page. Again, it's really blank, right? Because I want you guys to figure out how to build this table. But think about the labs we've been doing so far. That you guys can figure out where to put variables in unit. Right? But on the back of that page are set up 6 graphs, or well, the axes anyway. Right? So you will be able to, based on your data, either do 1 or 2 of these graphs. And I went ahead and put the suit in here so you can follow it. Like if you have the clubs here, okay, well, I can definitely do this graph, but maybe not the other ones. Okay? But tomorrow, this is going to be tomorrow's adventure. We're going to come back to tomorrow's class. I'll get data from you guys, and we'll put together all the graphs. Okay? Right, guys get that? All right, so I'm going to give you guys as much time as I can. Everything you need is back in the lab area. I will walk around and help you guys out.